Today we're going to be having a look at the parametric equations and proof homework. So we've got question 1, which is the parametric equations 1. We're given a parameter t that defines here both x and y. So if you put in a value of t, you can work out x and you can work out y from this. So part A asks us to work out coordinates of the points where t equals 2. So we've got our two definitions, our two parametric definitions, and we've got our t equals 2. What we're going to do is we're going to put t in here to get the x1 and t into here to get the y1. So nice and simply we get x is 2 squared plus 1, which is 5, and y equals 4 over 2, which is 2. So we get 5, 2. Those are our coordinates. For part B, we're asked to find the value of t on the point that has this coordinates here. So we've got 5 over 4 and minus 8. So for B, we've got 5 over 4 minus 8. These are our coordinates. So this is what our x1 has to give. So using our definitions up here, we can write down t squared plus 1, which is our x definition, is 5 over 4. Make sure you get these the right way around. This one's the x, this one's the y. We've also got our y definition, so we've got 4 over t equals minus 8. And we need to find the t value that works for both of these two things. Can't work for just one of them, has to work for both. So if we do this one first, we get t squared equals, if we take 1, that's like 4 quarters, so we're left with 1 quarter. And if we square root, we get t equals plus or minus 1/2. For this one here, we get 4 over t equals minus 8. Multiplying up, we get 4 equals minus 8t. Dividing by this, we get t equals minus 1/2. As we can see, this one works here, and it works for this one, but the plus one here doesn't work. That would correspond to a different point on the curve. So our answer for this is t equals 1/2, minus 1/2. The plus version here doesn't work because it doesn't agree with the y coordinate. It's going to give us a different point, and that's that question done.